Welcome to 2.1 in Math 30-1, where we talk about radical functions and transformations. You dealt with radicals in Math 20 in Chapter 5, and some of that is going to come back to, maybe not haunt us, but some of those skills we have to still be able to do. Things like converting from entire radical to mixed radical or solving radicals. We're going to run into some of that in this chapter, but most of this chapter focuses on the idea of taking the function f of x is equal to root x and then applying our transformations. And those are a times the function evaluated at b times x minus h and then plus k. Now, if I apply that to specifically the radical function, then what we see happening is I could now, with this transformation, write the new transform graph as a times the square root of, and everything in the square root is b times x minus h and then plus k on the outside. Now, that's the transformations that we've learned in Chapter 1. Nothing is going to do anything different. This is a vertical stretch by the absolute value of a. If a is less than 0, I'm going to draw it. We reflect over the x-axis. It's a horizontal stretch by 1 over the absolute value of b. But if b is negative, then it's a reflection across the y-axis. We have a horizontal translation by h units and a vertical translation by k units. And again, if h is positive, we go to the right. I'll write that in a sec. Smartboard's just taking a minute to catch up here. I'll put that if h is greater than 0, we go right. If h is less than 0, we go left. For k, if k is greater than 0, we go up. And if k is less than 0, we go down. All of this is wonderful. I like the idea of that kind of summary, that if we took a point on the original function, we'll talk about those points because you have to know what y equals root x looks like to do this. This is going to turn into 1 over bx plus h, comma ay plus k. That mapping is very consistent across this transformation language, so we'll use it again and again and again. But we're going to get into transformations as we work through the notes, but before we do that, I want to talk a little bit about y equals root x. Because in order to apply transformations, we have to know what the basic function looks like. Now, immediately, because the index is even, and you don't see a lot of questions that talk about cube roots or fourth roots or fifth roots, most of chapter 2, almost exclusively, deals with that 2 index, so the square root of a function. Because it is the square root, the inside, the radicand, must be greater than or equal to 0. And that's going to be really important because that becomes our domain restriction. Right? That lets us know where this graph exists and where it doesn't. Now, because of that, I'm not going to draw the whole Cartesian plane because anywhere to the left here, x is less than 0, that's not going to be applicable. And below here, in this particular section, we're going to get negative y values. Those actually don't happen when you take the square roots of positive numbers. And that's going to be a really important consideration, that this isn't y equals the positive negative square root of x. That's the inverse of y equals x squared. That's not what this is. This is just y equals, the most basic is the positive root of x. Now, the best way of dealing with that then is to pick some values of x and see what y is. Now, I think logically we're going to pick the smallest value of x possible, which is 0. When x is 0, y is 0. We'll plot these in a second. When x is 1, y is 1. And here is where the numbers you choose start to kind of get a little bit worse. If I pick x equals 2, y is root 2, which is 1.41 and a bunch of stuff after. If I pick 3, y would be the square root of 3, which is 1.73, and again, that decimal carries on forever. But if I were to choose 4, we get that nice number 2, which is the square root of 4. And that's why I'm not going to write, 5 and 6 and 7 and 8, because really the best numbers to use for x are those perfect squares. So if I chose 9 and 16, and maybe I'll do one more, I'll do 25 down here. When x is 9, y is 3. When x is 16, y is 4. And when x is 25, oh, I almost messed up there, y is 5. Now, I'm not too worried. Your calculator can do a better job of this, but some important points on this curve are the origin. Then it goes up to 1, 1. Then we're going to go to 4, 2. Then we're going to go to 5, 3. Sorry, 5, 3. That's 9, 3. My bad. And then we're going to go to 16, 4 somewhere over here. And then what this graph looks like is this. Now, one of the important considerations, and I'm going to write this in big angry red letters. Geez, I can't talk. It is not linear. right? And that's really important that the slope of this function isn't constant. You can see that it's quite steep right here, and then it does level off quite a bit on those red dotted lines. Some other important considerations are the domain and range. So if y is equal to the square root of x, then x must be greater than or equal to 0, but any real number that is, and y must be greater than or equal to 0 and any real number that is as well. All right, that's kind of the basics of 2.1. What we're going to look at in more detail in the actual examples is how to transform this. And some of this is certainly going to be how can we plug it into our calculator to confirm what we've transformed or what we've graphed.